Hi, this is Barrett Givens, and in this video, we're going to talk about the definition of a basis in topology. So the definition is, let's say you have any set X. A basis B is a collection of subsets of X which satisfies two properties. So the term that we're defining here is basis, okay? And the two properties are, the first property says for every little a in capital X, there is a set capital B in cursive B, such that little a is in B. So this is kind of like a coverage property, that every point in your space is inside one of the sets from the basis. Okay? The second property is an intersection property. Whenever you take two sets in your basis and you intersect them, and that intersection contains a point C, so that means the intersection is not empty, that there's some third set in your basis where the point C is inside that third set, which is a subset of the intersection. Okay? And just as a note, we call the sets in B, we call them basic open sets. So the properties say that every point is inside some basic open set. And when you intersect two basic open sets and they have a point in their intersection, there's a third basic open set. All right, let's just draw a Venn diagram real quick to make sure that we kind of understand what both of these things are saying. So the first one is saying if I have a set X, no matter what point I take, there is a basic open set around it. So any point that I want to look at, any point that I find anywhere, there's some basic open set that contains it. Okay? And so the basic open sets have to cover the whole space. All right? The second one says, I have, here's my space X, and let's say I take two basic open sets, and I have to draw them to overlap because I'm going to assume that there's some point in their intersection. So their intersection here is this part where they intersect. And let's say that I have some point in there, capital C, sorry, little c, that there's some third basic open set that is inside of the intersection and contains the point C. All right. So that is the definition of a basis. Okay, let's do our first example of a basis. So our first example of a basis is to say, let's suppose we have all real numbers, and our basis is going to be the collection of sets that are in the form of open intervals, a comma b. So the set of all points greater than a, less than b, where a and b are some real numbers. Okay, so my basic, my space is a number line in this case. It's the real number line. This is my space R. And my basic open sets look like, if here's an A and here's a B, they're the points that go from A to B with open parentheses, okay? So not including the endpoints, A to B. All right, so first of all, let's think about, does this satisfy the definition of basis? So is B a basis? Well, the first axiom of being a basis, or the first part of the definition of being a basis, is this like coverage axiom. Are there intervals? Is there any point on the real line that could not be inside of some interval? Think about like random points on the reals. Like if I take this point here, is there an interval that contains it? Sure, I can just draw an interval by going a little below it and a little above it, right? Or if I take a point, way down here somewhere, can I find an interval around that? Sure, just go a little above it and a little below it. So formally, maybe I'll say, let's let A be a real number. The set, I said a little below, a little above. What if we just go one below, one above? A minus one, A plus one. It has the form of the sets in this basis. It's an open interval, so it's a basic open set containing A. Okay, so that part of the definition is satisfied. Okay, and then the second part of the definition is consider two basic open sets. Let's say A comma B and C comma D. So that's my capital B1, capital B2. So A comma B looks like like that. And then C comma D maybe looks the same. And I want to assume that they have an overlap because the whole point is that we want to see if there's a point in their overlap. So I don't want to draw C comma D way over to the right or way over to the left. They have to overlap. And I don't, it could look like this. Like this could be what CD looks like. Or CD could be something where it actually goes, it's actually goes bigger in both directions, or CD could look something like this, right? So as far as how C and D relate to A and B, I don't really know for sure. But let's just think about this first case. In the top case, then their intersection would be the part that just goes from here to here. That would be their intersection. In the middle case, the intersection would be just A to B, right? And in the bottom case, it would just be like this part. So there's different sort of possibilities. But let's think about the top one. So let's say I take a point here. I'm going to call this point Y because I've already used the letter C for another purpose. So let's say I have a Y in there. Is there a basic open set that contains Y and is inside of that intersection? Yeah, in this case, I would say Y is in the open interval from C to B, right? Or down in the bottom case, if I were looking down here, the Y would be in the open interval from A to D. Okay, so here's what I claim. Let's let, oh shoot, I am running out of letters. Let's let P be the maximum of A and C, and let's let Q be the minimum of B and D. So P is just whichever one is bigger between A and C, and Q is whichever one is smaller between B and D. Then AB intersect CD is equal to PQ. When you intersect two intervals, you get another interval. Unless you get an empty set, but we're assuming we're not getting empty set here. So when you intersect two intervals, you get another interval. And so if Y is in AB intersect CD, then Y is in PQ, which is clearly a subset because it's actually equal. And so that's the second definition of being a basis. Okay. So in this case, we had something that was actually stronger than the basis definition, which was that when I intersect two basis elements, the answer is actually equal to another basis element. So if I go back to my previous picture, it's like the C that I drew here, or the third set that I drew here, if that third set was actually just the intersection itself, that's one thing that could happen, that did happen in this example. Okay. So that is the definition of a basis, and then the example of this collection of all open intervals on the reals. Okay, thanks for listening.